Okay guys, so the next question is find pair given difference. This is on GFG. The question says given an array ARR and an integer x, return true if there exists a pair of elements in the array whose absolute difference is x, otherwise return false. So basically it is said that we are given this array of integers and a single integer x. So now you need to return either true or false. You have to either return true or false based on if there exists a pair. If you can pick out any two integers from this ARR array whose absolute difference, that is, ignore the sign, maybe there is a negative sign in front, we don't care, the absolute difference of those two elements would result to be 78. Like for example, here I can say 80 minus 2 will give me 78, so I return true. Coming to the second example, see, there is we need to create a difference of 45. So for this 90, is there any element with which I can subtract 90 or subtract that element from 90 and we get 45? I think no. Similarly, check for 70, check for all the elements, we won't be getting any pair. So we are returning false. Over here there is only one element. So one element from one element, I can like obviously the x should always be 0, right? So that is the thing guys. So we need to either return true or false. So previously if you have done 2 sum, this is a lighter, one level lighter. There we had to return the index of the integers that were forming the target element. Here we don't need to even return the index of the elements which are forming the difference. We just need to return true or false. So obviously the absolute brute force approach that is coming to my mind is, I have taken an example over here. Let's see, the difference that is required is 4. So the absolute brute force approach that is coming to my mind is, when I am starting to iterate through the array, I get a 14. So now I need to check, is this 14 a part of our pair which will create a difference of 4? So for that I need to check what? Suppose if one of the numbers are 14, then either 18 minus 14 will give me 4 or 14 minus 10 will give me 4. So whatever it is, I would either need to look for a 18 or a 10 if I want to make this a part of our answer. Like it won't be the part of the output or the return that we'll be returning, but we need to find a pair with a given difference, right? So with this 14, either an 18 or 10 can pair up to form this difference of x. This point is very necessary. So okay, so I would need 18 or a 10. I can calculate that easily. How can I calculate this 18? Obviously, this ARR of I, which is 4, ARR of I plus x will give me 18. This ARR of I is 14 and x is 4, it will give me 18. And how would I get this 10? The ARR of I, this particular element, minus of the x, the difference, that will give me what? That will give me this 10 over here. So these two things I need to look for at every iteration. So for this 14 I would need a 18 and 10. I will look for a 18 or a 10 in the entire array. I will not be finding one. So what do I need to do? I will then move my focus to this 5. Now for this 5 I would need what? I would need either a 9 or a 1 in order to make a difference of 4. I hope you are getting how 5 plus 4 is 9 and 5 minus 4 is 1. So I will keep looking for 9 and 1 in the entire array. So obviously when I reach this index 4, I will find 9 and there I can directly return true. Okay, there exists a pair whose difference, absolute difference, is equal to x. We can return true then and there. And after checking this entire thing like that, for each element I will be looking for that element plus x and that element minus x. If I find it, I return. Otherwise I will just keep on moving forward. And if the entire loop, which will be a nested loop, exhaust, then I can come outside and return a false. Now looking at the code of this guys, there will be an outer for loop which will, this I loop will run from 0 to the whole length less than n, and inside this my j loop will also run. Like for example guys, I don't need to run my j loop for the entire length from 0 to n, because if any earlier element would have been a part of that array, we would have got its partner element towards its right already. So what I can do is, we can optimize this a little bit, run it from I plus 1 to less than n, and as we are making a pair which are two different numbers, what I can do is I can iterate this to 1 plus less, so that with the last element this less than n minus 1, so that the second last element can make a pair with the last element. So that's why we are not iterating till the last element. The last element will not have any number to pair with. What I need to do is, I will look for inside this j loop, I will look for if the current element is equal to if ARR of j is equal to what? The two numbers I am looking for are this ARR of I, ARR of the outer loop I plus x, or ARR of I minus x. If we find any of this, then I will just return a true. And I will close my loop. And if I come out of this loop and this true was not written from here, then I can say that there exists no such pair, so I can return false outside. This is the brute force approach. I hope you will try it on your end, guys. Now I'll move to the optimal approach. So obviously, if you have done 2sum, this is a very similar logic, but over here I told you that this is one step lighter. There in 2sum you need to return the indices as well. Here you don't need to return the index, you just need to return true or false. So basically, you don't even need to store the indices. You can just store the element that, okay, this element has occurred earlier. Now if I find its partner element going forward, I will return true then and there. So how would it work? Suppose I will copy the same example for 1457,294. Here I only need to store the elements and not the indices. So instead of a hash map, I can use a hash set. Hash set is nothing but a kind of collection framework, or you can refer to it as a data structure that stores unique elements. So this hash set is there. So over here, as soon as I come across a 14, I will look for, is in this set 18 or 10 present? None of them are present. So I say that, okay, no problem, I add up this 14 over here, so that if in future another element requests 14, it is there. Okay, then I have a 5. Is 5, for this 5 I would need either a 1 or a 9. Are any of those things present over here? Until now, is those elements present in this set? No. Okay, no problem, I'll add this 5. Now this is a 7. For this 7 I would need either a 3 or a 11. Do I have those in this set? The answer is no. So I just add this particular 7 for now. Then I move to this 2 over here. This 2 will check for either a minus 2, because with 2 if we subtract minus 2, then we get a 4. Obviously negative integers are not allowed in this array if you check the constant part, but okay, I can check it, right? And with this I can also add 4, which is 6. So 6 minus 2 will also give me 4. So is 6 present? No. Is minus 2 present? No. So okay, no problem, we put this 2 and then move ahead. Then we come across a 9. For this 9 I will need to look for either 9 plus 4, which is 13. Is 13 present? The answer is no. Then I look for 9 minus 4, which is 5. I look it over here. Is it present? The answer is yes, it is present in the hash set. So then and there I return true. And suppose, for example, if this was 8, for example, then the answer would have not matched, and I hope that, okay, it would also match for 8 and 4. Suppose if there is a case where no answer is possible, the entire loop will exhaust, and that if condition will never match, that if this set contains these elements, that if condition will never match and will move outside. I hope this is pretty simple for you guys. I'll just code it up, right? Int n equals to ARR dot length, right? Then I'll make a hash set which is which will be holding integers. Set, I'll name it set equals to new hash set, right? After that, what I'll do is I will iterate through the whole array, and I equals to 0, I less than n, and I plus plus, right? And then in that hash set, for the current element, I'll try to find out the current element plus x and also the current element minus x. So if in my set, if my set contains ARR of, what am I looking for? If the set contains ARR of I plus x, or set dot contains ARR of I minus of x. If any of these numbers are found, I can return true from here directly. I hope it is clear. And if not, I will, if the partner elements of plus x or minus x is not present, I would need to add the current element to my set so that a future number can have access to this. And obviously over here we don't need to store the indices. Set dot add, I'll do what, I'll add the current element, which is nums of I, right? After that, over here I need to return false. If we have not written true from inside, we will be returning false from outside. The internet is back. I'll just compile and run this. I have not changed anything. So it will be set dot put, right? Sorry, it will be set dot add, but it should be nums of I, not sorry, ARR of I, not nums of I. Okay. And it works for all the test cases, right? Yeah. Cool guys, thank you.